Hi there, today's lesson is on types of graphs. Now you'll have come across different types of graph already in other lessons. You'll have looked at probably straight line graphs, you'll have looked at quadratics, you might even looked at cubic, and certainly you'll have looked at inverse proportion potentially, or 1 over x graphs, lots of different types of graphs. But essentially you need to be able to recognise them, know the names of them, and obviously coming GCSE exam time, you have to kind of regurgitate them essentially. All right, so types of graphs. Okay, so let's kind of get going on these. So you need to be able to identify all the different types. Now, linear is one I've kind of already mentioned. Linear is essentially a straight line graph. All right, and there's kind of clues in the word because it says line. So it would either go straight up or straight down, or it could be horizontal or it could be vertical. It doesn't really matter as long as it's a straight line. So linear is a straight line. Okay, a quadratic, same thing. Is that you'll come across this before. These look like parabolas, all right, so they take like a little U shape or a little N shape, so looking a little bit like that. And they're normally to do with some x squared value, isn't it? So this will be a positive x squared graph, and this will be a negative x squared graph, or more than likely, all right. So U or N shape, or like I said, they are parabolas, and they are symmetrical, all right. So if we put a line down the middle there should be a line of symmetry that goes in between them, all right, and that's something else to be mindful of when thinking about it. And again, same kind of idea, thinking about if I had the two roots here, and now how I could figure out this one if, again, I had a line of symmetry. So the distance between these two, halfway, would be where that one is. All right, just something to think about if you're looking at other lessons, but that's a quadratic. All right, so cubic, all right, so this one here, it doesn't turn at all. All right, so normal, just y equals x or something like that, y equals x plus 2, something that looks like this, where you've got a straight line, just a value of x, doesn't turn. As soon as I set to x squared, so your power of x goes up by 1, and then I've got it turns once. Okay, so when I'm looking at cubic, we're talking about x cubed, my power of x has gone up again, so it's going to turn twice, so it's going to take this kind of shape, so it's going to go up, and then back down, and then straight back up, all right? And it's similarly with negatives, it's going to take that shape. It doesn't have to necessarily have two, like a bottom and like a maximum and a minimum, use the correct words, so it doesn't have to go up and then back down. It could go up and then like level off and kind of go back up. So if you're looking at a tan graph, that would be classed as look like a cubic, because it kind of goes up and it flattens off and then it goes back up, it turns twice. Okay, so just be mindful of if you're looking at specifically a tan graph, could be confused with a cubic because ultimately it's kind of turning. All right, but normally it kind of takes 2 turns and then back up again. So they're your cubic graphs. All right, takes a next type of shape. Okay, a reciprocal graph, that's like 1 over x or something like that. So that's going to look a little bit like this. So what's going to happen is that when your x is very, very small, or 1 divided by a fifth, it's going to be 5, or 1 divided by 100, it's going to be, sorry, 1/100th is going to be 100. So it's going to get bigger and bigger and bigger as it closest to 0. And similarly, when you're talking about negatives, well, again, a very, very small, 1 divided by a very, very small negative is going to give you a very, very big negative value, so hence all the way down. And as you get, number gets bigger and bigger and bigger and bigger, and if I said 1 divided by, for example, 1,000, that's going to give you a very, very small value, but it never reaches 0, so your axes, in this case here, are what we call asymptotes, never actually touch it. It'll get smaller and smaller and smaller and smaller and smaller and smaller, but it'll always give you some value, even if it's very small. So that's your reciprocal graph looking like that. And again, where the axes, and it says here, are asymptotes. So the two parts of the graph of asymptotes never touches the axes. Okay, so that's a reciprocal graph. And then an exponential graph. Well, again, if you've looked at the lesson on exponentials, you'll probably know what this looks like. But ultimately, it gets bigger and bigger and bigger and bigger and bigger as you go. All right. And because we're talking about something to a power, then this is why it kind of doesn't going to go beneath the big 0 here. Because if I said something to the power -5, well, that means 1 over something to the power 5. It's still a value, it's still positive, but of course it will just be along here. All right, so it'll never going to reach the x-axis, because it'll always give you some value for y, just a very, very small one. And if I said x to the power, sorry, 5 to the power x, no matter what my x value is, it gets bigger and bigger and bigger and bigger. Obviously, it's going to balloon up, but it's going to exponentially go there. So a graph which grows very fast and never meets the x-axis can never be negative. Okay, so there are your first 5 types of graphs. We're going to look at equations with that. So enable to identify different types of graphs from their equations specifically. So maybe you're not given the graph to look at, but maybe you're just given an equation, and I kind of touched upon it already in terms of what to look for. So when we're talking about a linear graph, you'll recognize it as this. All right, it'll be y equals some value of x plus c, And again, 3x, 4x, 5x, it's just x, isn't it? Okay, there's not an x squared or x cubed or anything like that, it's just a value of x, all right? So that would be a linear graph. A quadratic, and again, if you've done quadratic formula, you'll recognize this one, but it's an x squared graph, essentially. So some value of x squared, it could be 1, and it doesn't really have to have these bits. It's essentially anything with an x squared value is going to give you a quadratic graph. So your power of x's are starting to kind of increase. Cubic, well, I hopefully get the idea of it now. Then I'm going to have something cubed. And again, I'm not necessarily, you don't have to have an x squared or have to have an x, you have to have a number. You don't have to have those, but it's as soon as you see the cubed part of it, then it's a cubic graph, essentially. Okay. A reciprocal, and again I mentioned it, is basically something over x. All right, so basically 1 over x or 2 over x, doesn't really matter what that number is, because when you're divided by x, obviously it's going to get bigger and bigger and bigger and bigger, and as a result, that's what gives you those kind of shapes. And you know, if you want to try those things and plot them and see what happens, I promise you will end up with graphs that look like the ones you saw on the previous slide. And then the last one, of course, is an exponential graph, which is basically something to the power of x, and we kind of tried to mention that in the previous lesson. So that's what they all look like from a equation point of view. But of course, you know, it's never straightforward like that in an exam. You've just got to try and think about which of these aspects that you need. So if a quick run through, it's just x on its own, no higher power. X squared, all right, you can have these if you want, and then x cubed, and then for reciprocal, it's something over x, and then exponential, it's something to the power of x. Okay. So what type of graph is this one? Well, y equals 4x squared. Well, the highest power is in x squared, so I can ignore all the rest, so that's going to be a quadratic. Okay. And look at this next one. Well, this is to a power x, so that's going to be an exponential. And then over here, again, which is the highest power of x, so x cubed, so that is going to be a cubic. All right. Right, so a final little bit, which is proportion. Okay, so if you've done the lesson on indirect and direct proportion, this will make sense. If not, you might want to look at this one, that one before this one. But can you identify if something's proportional to something or not? All right. Well, in here you can see you've got a straight line. All right. So they're directly proportional. Now, as one goes up, so does the other. All right. They are directly proportional to each other. Okay. Straight line graph. So if something's proportional to an x squared graph, all right, this is what happens to the graph. All right. So as something basically goes up, then it's squared. All right. So it takes this shape. And you're probably kind of questioning is why it doesn't go negative, because we're talking about something increasing. Is increasing in relation to something being squared. All right, so it's basically this part of a quadratic graph, just this part. All right, so if I continue it that way, then it would go that way. But I'm not talking about something being negative. It's about my y being proportional to x squared, essentially. Okay, so a curved graph with an increased gradient. Right, so y is directly proportional to the square root of x. Well, it's kind of the opposite of this, isn't it? So rather than kind of going like slowly up and then like increasing, it's going to go up fast and then slow down, essentially. All right. So y is directly proportional to the square root of x. All right. And I suppose you could try and put some numbers in and write that as an equation using the direct proportionality part of it. You could put y is equal to k root x and then put those numbers in and see what happens when you put the numbers in. Same over here. You could put y is equal to kx squared and then put some values in for x and see what happens, and I promise you it will take that shape. Okay. So y is inversely proportional to x. So this is going to be y equals k over x. So this is going to look like what we call the reciprocal graph, essentially, isn't it? But you'll notice what we're seeing is just the positive side of all these. So there's not things on the negative side. There's nothing on the negative side. There's nothing on the negative side. We are purely seeing just this part of it, right, on the right hand side. So essentially, as x obviously gets bigger and bigger and bigger and bigger, when you divide it by that, x obviously it's going to get smaller and smaller and smaller and smaller and smaller. All right, so inverse proportional to x, and then direct proportion graphs must pass through 0. All right, so they've got, if something's directly proportional to something else, then when one is 0, the other one is 0. All right, unless it says something else, because you'd have to say if it's essentially proportional to something plus something else, but of course it's not. We're talking specifically, there's no other variables involved, there's no other numbers involved, and please do look at the lesson which is involving direct and inverse proportionality because what you do with that, you normally work out y is equal to kx squared, and that gives you a value for k, which is the constant proportionality. But of course, at this point, when x is 0, well, it doesn't matter. If I square it, obviously it's still going to get 0, and it doesn't matter what I times it by, it's going to go through 0. And that's the same for all these kind of equations. They're all going to pass through 0. All right. Inverse proportional graphs are never straight. All right. So you'll see that inverse proportional, never straight, well, because again, same kind of idea. It's going to be 1 over. It's a reciprocal graph essentially. Okay. So please do look at the kind of lessons on direct inverse proportionality to kind of remind you on those kind of concepts. Obviously, come back to these lessons and look at the graphs again if you need to, but get yourself on maths-school.co.uk for a bit more practice. Thanks for listening.